Hello everyone. Today I am going to discussing about the previous questions for the queuing theory problems. This is I will be discussed with the following examples. So before going to discussion of the previous questions, first I will be discuss about the basic terms and notations generally using in the queuing theory. First one is mean or average arrival rate. So that is lambda, which is defining as number of customers arriving per unit of time. For example, if the two customers are arrive in every 5 minutes, then here lambda will become 2 by 5 customers per minute. Second one is mean time between arrival. So that is we are giving notation as 1 by lambda. So which is the reciprocal of the mean arrival rate. So next one is the mean service rate. So that is here we are giving the notation is mu, which is defining as number of customers served per unit of time. So let's see the example. If one customer is served in 5 minutes, then mu equal to the 1 by 5 customer per minute. So next one is the mean service time. So that is 1 by mu. So which is the reciprocal of mean service rate. So next one is the queue length LQ, which is defining as average number of customers in the queue waiting to get the service. So this is the execute the customer being served. So here we are considering the only how many number of customers are in the queue to waiting to get the service. So next one is system length LS, that is defining as average number of customers in the system, which is including the those are waiting as well as being to be served. So next one is waiting time in queue. So which is defining as average time customer has to wait in the queue to get the service. So next one is waiting time in the system. So which is defining as total time, waiting time and also servicing time. So waiting time in the system means average time customer has to be spent in the system, which is including the waiting time as well as servicing time. So last one is the utilization factor or maybe traffic intensity, which is giving the notation as rho, which is defining as lambda by mu, that is mean arrival rate divided by mean service rate. So next to see the notation, small n is the number of customers in the system and capital N is maximum number of customers allowed in the system, that is the capacity of the system. Pn is the probability of n customers in the system and lambda and mu we already discussed. So lambda means average customer arrival rate, mu is the average service rate and rho is the traffic intensity, which is defining as the so lambda by mu, and P naught is the probability of no customer, S is the number of service channels, N is the capacity of the system or maximum number of customers allowed in the system, LS is the so average number of customers in the system, LQ is the average number of customers in the queue, capital L is indicating average length of non-empty queue, WS is average waiting time in the system, WQ is the average waiting time in the queue, and PW is probability that arriving customer has to wait. Here we have the three queuing models. First one is the single server with exponential service of the unlimited queue. Second one is the single server with exponential service for finite number of the queue. Third one is multiple servers with exponential service for the unlimited queue. These three models we will be discussed with the previous question papers. First one is I will be discuss single server queuing model, especially for the single server with exponential service and unlimited queue size. See here, you have to remember the 10 formulas are there. You have to remember all the formulas and substitute the lambda and mu values in the formulas. You will get the solutions. So what are the formulas mean? See, remember, so these formulas are for the single server queuing model, especially for the unlimited queue. So in the data, if you identify that one given queuing model is having the single server, only one server and unlimited queue size, then you have to apply these formulas. First formula is probability that server is busy. So that is giving notation as PB. So that is lambda by mu. Second one is probability that server is ideal. That is P naught, which is nothing but 1 minus PB. Otherwise 1 minus lambda by mu. Third one is probability that there are n number of customers. For example, 5 numbers or maybe 6 numbers, 2 numbers like that. So third formula is probability that there are n number of customers in the system. Sometimes maybe problem they will be asked, find out the probability for the only 3 customers are there in the system. Then you have to use this formula. That is here Pn. Pn is probability that there are n number of customers in the system. Pn equal to lambda by mu whole to the power of n into P naught. That is lambda by mu whole to the power of n into 1 minus lambda by mu. Let's see the example. If there is only one customer is there, then what is the probability? If n equal to 1, then you have to substitute small n equal to 1 in the previous equation. We will get the Pn equal to lambda by mu into 1 minus lambda by mu. If it is they ask, if the 2 customers in the system mean, then n will become the 2. Then have to substitute n value in the previous equation. You will get the P2 equal to the lambda by mu whole square into 1 minus lambda by mu. Next, fourth one is probability that there are number of customers is greater than or equal to a given number R. That is P of n is greater than or equal to R equal to the lambda by mu whole to the power of R. So next fifth one is probability that there is a queue is non-empty. For this, P of n is greater than or equal to 1 equal to lambda by mu whole square. So next formula is average number of customers in the system, that is LS, equal to lambda by mu minus lambda. Next formula is average number of customers in the queue, that is LQ, which is equal to the LS minus lambda by mu. So that is the equal to the lambda by mu into lambda by mu minus lambda. So next one is average waiting time in the system, that is WS, which is equal to the LS by lambda. And next one is the average waiting time in the queue, WQ, which is equal to the WS minus 1 by mu, which is equal to LQ by lambda. And last formula is average length of non-empty queue, that is Ln, which is equal to mu by mu minus lambda. Let's see the example problem. A person repairing radios. Find that the time spent on the radio sets has an exponential distribution with mean 20 minutes. If the radios are repaired in the order in which they come in, and their arrival is approximately Poisson with an average rate of 15 for 8-hour day. What is the repairsman's expected ideal time in each day? How many jobs are ahead of the average set just body? So this is the given in March 2017. Let's see the solution. First step is we have to identify the queuing model. For this one, first we have to observe the given queuing model having the single server or multiple server. See, by reading the problem, I observed that one here having the only one repair person. So it is the single server. And one more thing you have to observe that one, there is any restrictions in the queue size. So based on the given data, I observed that one. So given problem having the unlimited queue. So given queuing model is single server and unlimited queue. Next step is we have to identify the lambda and mu values from the given data. See here how to identify the lambda and mu values mean. First we have to observe the any words related to the arrival and Poisson distribution. See here in the problem, I observed that one. Here Poisson word also there and arrival words also there. So just we have to observe this sentence up to here. Just have to observe this sentence here, which is the given. So then I have to observe that one. If it is given customers per unit time or it is given only unit time. In this sentence, I observe that one. It is giving that one average rate of 15 per 8 hours. So it is nothing but customers per unit time. So it is when it is the given data is related to the customers per unit time, it is the lambda. Otherwise, it is given the only unit time, that is related to the 1 by lambda. So similarly, we have to observe the words service and exponential distribution. See here, I observe the exponential distribution. So let's concentrate this sentence. And one more thing you have to observe that one. Here, customers per unit service time. And also I have to observe in the given data, it is mentioned only unit time. Here I observe that one 20 minutes. So here only given data is only for the unit time. So it is the 1 by mu. So next third step is, write the required formulas and substitute the lambda and mu values. So first step is identify the queuing model. So here identify the given queuing model is single server and unlimited queue. Then we have to identify the lambda and mu values from the given data. So from the given data, I observe that one. So lambda value is 15 per 8-hour day. Is nothing but, so lambda equal to 15 customers by 8 hours. Here customers are the radio sets. Is nothing but 15 radio sets divided by 8 hours. It's nothing but 15 by 8 sets per hours. It is nothing but lambda equal to the value is 1.875 sets per. And second thing, I observed that given the only unit time. So that is related to the 1 by mu. So 1 by mu is given 20 minutes per set. So 1 by mu equal to 20 minutes per set. One more thing you have to remember, all the data should having the constant unit times. See here, lambda is given in the hours, but 1 by mu is given in the minutes. Then you have to convert hours into minutes or maybe minutes into hours. Here I converted minutes into the hours. So 20 minutes is which is equal to the 1/3 of hour. So 1 by mu equal to the 1 by 3 hours per set. So 1 by mu equal to 1 by 3 mean, so then mu equal to the 3. So mu is nothing but, So 3 sets per hour. So next one we'll move to the third step. So in the third step is we have to substitute the lambda and mu values for the required formulas. What are the required formulas are required here? See here, we have to determine the expected ideal time in each day and also have to determine the how many jobs are ahead of the average sets just about it. So what are the required formulas here mean? So let's see here expected ideal time. So we know that one probability of the server is ideal. We know the formula P naught. So P naught is nothing but server is ideal. Here we have to determine the ideal time. But we know the only probability of the ideal. So that is the P naught equal to the 1 minus lambda by mu. Just here substitute the lambda or the mu values. We will get the 0.375. So P naught equal to the 0.375. We know the probability of the ideal, but we need the ideal time. So probability of the, so formula for the ideal time is probability of ideal into working hours. Here working hours is 8. So 0.375 into 8. So this is the ideal time. So second thing you have to determine the, it's nothing but you have to determine the length of the system. Expected number of PV sets in the system, that is the LS. So LS is the lambda by mu minus lambda. Then you have to substitute lambda and mu values in this equation. We will get the 1.667, that is approximately 2. So this is the solution of a given problem. So this is the very simple. First thing you have to identify the queuing order. Second is you have to determine the lambda and mu values. Then you have to apply the suitable. So just have to write down the suitable formulas. Then you have to substitute the lambda and mu values in the respective formulas. One more shortcut is here. If you don't know so which formulas I should have to write down the, then write down the all the formulas. We have the only 10 formulas. Write down the all the 10 formulas and substitute the lambda and mu values. So you will get the answer. So thank you very much.